Welcome to this introduction to the series Circuits Part 2. I'm really hoping that from Part 1 you understood about current in a series circuit, why ammeters are in series, and you understood that we're using a model to help us understand and explain what is happening in our electrical circuits. So this part we're going to look at voltage. Voltage is possibly one of the most difficult things to think about. We can think about it in two ways in our model. Remember that there were no lorries on the road until we put the factory in there, because nobody needed to be on the road. Once we put the Mars bar factory there, suddenly we needed a way to get the Mars bars from the factory to the shops, which is why we've got some lorries. Another way you can think of as voltage is you can think about it as the number of boxes of Mars bars on each lorry. So boxes of Mars bars on a lorry equals the voltage. So boxes of Mars bars per lorry, which is equal to energy over the number of lorries, which is almost equivalent to our electrons or our current or our charge, is equal to the voltage. So it's Mars bars per lorry, and a lorry represents a big chunk of charge or lorries. What I want you to think about. So we're going to put Mars bar factory. We're going to put a manager in here, and she's in charge of deciding how many Mars bars go on every lorry. Obviously the same number of Mars bars go on every lorry, and she has made a decree that there are to be 15 Mars bars on every lorry. This lorry's just gone through the factory. How many Mars bars does it have? 15. This lorry's just been round and done its deliveries, and it's coming back to the factory. How many Mars bars must it have on board? It must have none. This lorry driver comes back with Mars bars on board. It's not going to be very long with the company. Now, can you stand at the side of the road and count the number of Mars bars on the lorry? No, you can't. And that's the same with voltage. With voltage, you can't put a meter in the circuit and expect to count the voltage across it. What you've got to do is you've got to sample. And that's like, if any of you have seen one of the weigh bridges, and the police sometimes make blockades along the motorway, and they call some of the lorries, they pull some of them off, and they weigh them, and they check what's inside. And that's what's happening here. And that's why a voltmeter, when you connect the voltmeter up, you put it across the component. Because what we're going to do is we're going to sample some lorries. We might take this one off, so all the others go through. We might sample this one and have a look. How many Mars bars it's got here, how many it was going to deliver here, and how many it's got there. And that would be the difference in potential, or the potential difference. So the difference in Mars bars per lorry from one side of a component to the other. And that's what you're doing with a voltmeter. So let's have a look. Here's a Mars bars, 15 in this lorry here. Now, it drives along here and it gets to here. How many Mars bars should it have? Well, it should still have 15 because it's not made a delivery. Now, Audi's a big shop and sells quite a lot of Mars bars. I think each lorry is likely to deliver about 8 boxes of Mars bars. So here, it's going to have 7 boxes of Mars bars left. If we count how many boxes this side, how many it delivered to Aldi, 7 here and 15 here, so it's delivered 8 to Aldi. Now a lorry goes along here. How many's it got here? Well, it's still got 7. No deliveries along here. Tesco's quite a big shop, so I think after Tesco, it's going to have 1 left. So how many did it deliver to Tesco? Well, it had 7 here. It had 1 here, so it's delivered 6 to Tesco. The lorry goes over the bridge. No loss in Mars bars there. And it's got 1 here. Okay, and we've said that it must have none when it gets back to this point. It also must have 0. Before Sandu stores and after Sandu stores, how many is it delivered? It's delivered 1 box of Mars bars. Now that's each lorry. What's special about this? Well, this Mars bar manager said it wanted to add 15 boxes of Mars bars to every lorry. And if we look here, we've got 8 boxes delivered to Aldi's. We've got 6 boxes delivered to Tesco. And we've got 1 box delivered to Sandu stores. And what does that add up to? That adds up to 15 boxes of Mars bars. What do you notice about that? Well, that's exactly the number of Mars bars per lorry that every lorry got. So if we relate that to voltage, the energy gets given to the charges as they go through the cell, and then they lose some of that energy each time they go through a component. They don't have to lose them equally, only if the brightness of the bulbs or the components are the same. But here we've met 3 stores and they're all very different in size. Aldi would get most, so that would be a bigger potential difference, and then Tesco the next, and Sandu the smallest. Now I've set that up on the FET, so let's have a look here again. So here's our model again, made up in FET, and you can have a play with this later. I've left one ammeter in, and I've taken the rest out. Notice the bridge is open, the switch is open, there's no current, there's no electrons flowing in this circuit, but the lamps are still there. Now the question is, if I put my voltmeter across the cells, would I get a reading? Well, think about the factory. Would there be Mars bars in the factory? Yes, there would. So in this factory, we've got 18 volts across the cells. What about if I put this across the lamp? So that's not getting any energy, as we'd expect. But if I close the switch and do the same thing, naughty, naughty, put my connections around the wrong way, that bulb is got a voltage of 6 volts across it. Let's just check out cells. That's still saying 18 volts. Okay, let's have a look at this bulb. Sorry that it's gone off the screen, but the connections are there, I promise. 6 volts there. So 6 volts across one lamp, 6 volts across the other. What should this be? This also should be 6 volts. It's like each shop is the same size shop, not like our little Sandu store compared to Aldi. We got voltage of 6 volts across here, 6 volts across here, and 6 volts across here. 6 plus 6 plus 6, 18. 18 volts from the power supply. It looks as if our model works. Just to show you that this works on our model, voltmeter on the right is across the component, so that's across the Mars bar factory. Then the one at the bottom is more like Sandu stores, so that has a voltage of 0.469 volts. The one on the left has a voltage of 0.586 volts, and the one at the top has a voltage of 1.779 volts. So add up those 3 and see how close you get to the supply voltage. Did you manage to fill in the whole model? Does the model make sense? Do you understand that if you use our model and think about what each thing in our model represents, it can help you understand what's happening with our electrical circuits. We're counting cars with ammeters, and you could put those in series. And we found that in a series circuit, all the counters counted the same number of lorries, and that shows that in a series circuit, the current stays the same. We said that the number of boxes of Mars bars per lorry equaled our voltage, because voltage is the energy per unit charge, per lump of charge. We said that the weighbridge was like a voltmeter, and you couldn't just stand at the side of the road and count what was on the lorry. They had to go in parallel, and we found out that the number of boxes of Mars bars per lorry delivered to each shop adds up to the number of Mars bars provided by the factory, which said that in a series circuit, the voltage across each lamp adds up to the total. And we know that we had the same number of Mars bars at the beginning as we did at the end, so the energy in the circuit is conserved. In our next episode, we're going to look at an improved circuit.